All right, guys, welcome to this page of the notes. Now, what we're going to do is we're going to apply what we have learned about solving systems of equations to word problems, all right, to word problems. So we're still going to be doing either substitution or the elimination method, but the catch here is now you've been given a word problem and you have to actually write your system of equations. Actually, let me say this. I'm going to give you these problems two ways. I can either give you one like this, where you will have to write your own equations, right? So we're going to need to first write the equations and then solve that system of equations. Kind of tricky. The second way I'll give you these problems, and we'll actually look at this on the next page, is I give you a word problem, but in the word problem I give you the information sort of set up in a table or a chart. Now, while technically I haven't given you the equations you need to solve, your equations are going to come straight from the table or the chart, which actually makes the problem considerably easier. So we are starting with the more difficult one here. This is about as tricky as they're going to get. And it's just because you'll need to pull the information out of the problem to write your own equations before you even start solving them. So let me give you a tip on how to do these problems. What you want to do is, as you read the problem, look for the numbers that represent a total. Right? Numbers that represent a total. And as we read the problem, we actually have two of them. At a park, there are 38 people that are playing tennis. Some are playing doubles, which I tell you the variable to use, D. Such a nice guy, I know. And some of the players are playing singles matches, which we'll use the variable S. There are 13 matches in progress. A doubles match requires 4 people. Singles match requires 2 people. I want to know how many of each kind of match is in progress. And what you should do is have recognized the totals. There are 38 people playing tennis. That is one of my totals. And then the other one is that there are 13 matches currently in progress, right? So those are the two numbers I've given you in the problem that represent a total. You will write those numbers and then come up with an equation that gets you those two numbers. Well, here we go. Let's go ahead and start with 13. Oh, hang on. Sorry, that is a highlighter. No, boy, no. Let's get a marker. There we go. 13. All right, well, the 13 tells me that there are 13 tennis matches currently in progress. Now, what kinds of matches are being played? Well, there are doubles matches and there are singles matches. And if you were to add the number of doubles matches and the number of single matches being played, you would get the total of 13. So if I added the doubles plus the singles, if I added all of the matches, all the double matches, and all of the single tennis matches that are being played, the total would be 13. So there's our first equation. My other total is 38. There's a total of 38 people playing tennis. Some of them are playing doubles matches. Some of them are playing singles matches. So the question is, how many people are required to play a doubles match? Well, I tell you, you need 4 people to play a doubles match. So 4 times D, right? Right, there are 38 people, right? And 4 are required to play a doubles match. So how many people are playing doubles? Well, figure out how many doubles matches there are, multiply by 4, and I'll know what portion of that 38 are people playing a doubles match. How many people does it take to play a singles match? Well, it takes 2. So how many people are playing in singles matches? Well, if I know how many singles matches are being played, I multiply that by 2 and I know how many people are in doubles matches. The point is, if I add all those people up, I get 38. Well, now all we need to do is solve this system of equations. I have 2 unknowns. I have 2 equations. We're good to go. Substitution would work. It would. I have both a D and an S with a coefficient of 1. You absolutely can do substitution if you want. But I'm going to do elimination. I don't know why. That's just what I'm going to do. So here we go. I'm going to multiply. Let's see. What do I get rid of first? Looks like I eliminate the s's, so I'm going to go ahead and multiply this guy by a negative 2. That's going to give me a negative 2s and a positive 2s. The s's will drop out, and I'm solving for d first. Again, substitution absolutely would work. It probably might even be a little faster. I don't know, it depends on how good you are at substitution. But at this point, we've done elimination so many times, you're probably pretty fast at elimination by now as well. And they might be a horse apiece, right? Substitution versus elimination. I don't think either one's going to save you much time in this case. So here we go. 13 times a negative 2 is going to be a minus 26. Equals a negative 2d minus 2s. 38 equals 4d plus 2s. Add them up. S's drop out. Negative 26 plus 38 is going to be 12. And the negative 2, that leaves me with 2d, which means d is going to be equal 6. There are 6 doubles matches currently being played. Now, how do I figure out how many singles matches there are? Well, I'll just plug the 6 in for d, solve for s, which means that I will have 13 is equal to 6 plus s, which means 13 minus 6 is equal to s, which means that s is equal to 7. 7 singles matches being played. Okay, great problem. Again, for word problems, this is actually the trickier one because I did not give you the equations. You have to pull the information out of the problem to write your own equations and then solve them. Remember, sort of the trick for doing this, the tip for doing it is find the numbers that represent totals. 38 people, total of 13 matches, and then write equations that would get you those totals. So let's try another one. On the next page of the notes, I got this problem here. What we've got is we've got a youth group, and they are headed to an amusement park. They are traveling in 2 vans, and the table shows you the number of people, adults and students, in the van, and then what it cost them to get into the park. What I want you to do is find the adult price and the student price of admission. Now, this is slightly easier. Again, technically, I have not given you equations, but the equations come straight from the table. Since I have students and adults, my variables are going to be A and S. Obviously, you can make the variables whatever you want to, but A and S make sense to me. My first total is $77. And how do I get $77? Well, that's from 2 adults and 5 students. My next total is $95. Well, where did the $95 come from? Well, that came from 2 adults and 7 students that were in the second van. Well, this one's actually not bad. I already have a variable with the same coefficient. Just want one of these guys to be negative, and we'll go ahead and make this one the negative one. So that means I have a minus 77 minus 2a minus 5s. I have a positive 95. I have a 2a. I have a 7s. Add them up. A's drop out. And what we wind up with is, let's see here, negative 77. If you've got a calculator there with you, we wind up with, let's see here, negative 77 plus 95. Negative 77, oh, sorry. Plus 95 should get you 18. Sorry, dropped my calculator. Gets me 18. Oh, hold up, there we go. And then, of course, a negative 5 and a positive 7 should leave me with a positive 2. Which means that S is equal. Since we're talking about the price of admission, that would be $9. Let me slide that up a little bit so you can see it, right? That would be $9 is the price for a student admission, $9. But now what I need to do is I need to find the price, because I asked for both. What is the price for an adult and what is the price for a student admission? So we go back and choose one of those equations. Doesn't really matter which one you pick. Maybe I'll go with that one. We do 77 is equal to 2a plus 5 times 9, which means 77 is equal to 2a plus 45. Subtract the 45, 2a is going to be equal to 77 minus 45. I get, an error. Hang on, 77 minus 45. How about 32? And we wind up with the price of admission for an adult being $16. Guys, that takes care of all of the problems in this section of the book, Chapter 3, Section 1. What you should now be comfortable doing is solving systems of equations, both graphically and algebraically, and then, of course, doing word problems if I give them to you, where you write your own equations and then solve that system. Thanks so much for joining me for this set of videos. I'll see you guys the next time.